In 2022, I was in my final year. I was going through medicine postings, and there was a case which was suffering from emphysema, got admitted in our ward. Our professor was like, "ये case के बारे में पढ़ के आ जाओ, we'll discuss it in detail tomorrow." So we were like, "वो book, ये video सबसे पढ़ के गए और we are pretty confident we will answer that." And हमारे प्रोफेसर ने पूछा, "What type of respiratory failure is this patient suffering from?" And we were like, "emphysema है, type 1 respiratory failure होगा." And our professor was like, "You are absolutely wrong." तो वी आर शॉक्ड इनफ एंड हमने फिर से पढ़ा और या टाइप 1 रेस्पिरेटरी फेलियर के अंडर ही एम्फाइसेमा था एंड वी सेड सर इट इज एम्फाइसेमा सो इट इज टाइप 1 रेस्पिरेटरी फेलियर और प्रोफेसर वाज लाइक फिर से देखो and then we went to the patient and then we saw the EBG values again of that patient and we got to know it is not type 1 respiratory failure. What mistake we made then? So at the end of this next 3 minutes you will understand what mistake we have made and how to rectify it. So before understanding respiratory failure, let's understand the alveolar apparatus. There is the alveoli and interstitium, then there is blood vessel. In the alveoli, we mainly have the oxygen because in the environment mainly oxygen is present, then carbon dioxide amount is very negligible. So the same air we inspire and in the alveoli mainly oxygen is present. So we measure only partial pressure of oxygen in the alveoli. Then in the blood vessel, there is presence of oxygen as well as there is presence of carbon dioxide, which is nothing but all the metabolites from the cells the blood has carried away. So the oxygen is also present and the carbon dioxide is also present. So we measure partial pressure of arterial O2 and partial pressure of arterial CO2. And in the interstitium, we will measure the gradient, that is partial pressure of alveolar O2 minus the partial pressure of arterial O2. So this gradient is called as PA minus A O2. In the partial pressure of arterial O2, the normal level is at 60 mm of Hg and partial pressure of CO2, the normal level is around 40 mm of Hg. Whenever the partial pressure of arterial O2 decreases below 60 mm of Hg, we call it as hypoxia. Whenever the partial pressure of arterial CO2, if it is more than 50 mm of Hg, we call it as hypercarbia. Now let's understand about type 1 respiratory failure. Type 1 respiratory failure is a diffusion defect. The membrane which is causing diffusion of oxygen and CO2 is defective. So we will understand this type 1 respiratory failure with the example of paper and two liquids. Now assume we are having a paper and water and a viscous liquid. Now whenever we pass the water through this paper, it will pass easily. And similarly, whenever we pass a viscous liquid through this paper, it will take some time to absorb and then it will pass through that paper. Similarly, here our oxygen is that viscous liquid and carbon dioxide is the water. So carbon dioxide, either the paper is thin or thick, it will pass easily. So as it is very less viscous. Similarly, our oxygen doesn't pass through that paper unless and until it is very porous paper. So similarly, whenever there is a diffusion defect, if at all there is a defect in the membrane, oxygen doesn't pass easily, but the carbon dioxide easily passes through that membrane. So in diffusion defects, the partial pressure of arterial O2 will be decreased because the oxygen from alveoli to arterial transport is decreased. Similarly, the partial pressure of arterial CO2 is normal because the carbon dioxide diffusion is normal. Now let us understand the examples of type 1 respiratory failure with the help of this diagram. Here the heart represents cardiogenic pulmonary edema and non-cardiogenic pulmonary edema. The non-cardiogenic pulmonary edema, the only early cases comes under this type 1 respiratory failure. I will say the reason why. Similarly, the blood vessel represents the pulmonary embolism and this alveolar apparatus, this part represents the obstructive lung diseases which constitutes of emphysema, bronchial asthma and bronchiectasis. Similarly, the alveoli represents the diffuse alveolar hemorrhage and the pleura represents the pneumothorax. So now type 2 respiratory failure. In type 2 respiratory failure, which is a ventilation defect, the amount of oxygen reaching the alveoli is decreased. As the amount of oxygen reaching the alveoli is decreased, partial pressure of alveolar O2 is decreased. So the amount of oxygen reaching the blood vessel is also decreased. So partial pressure of arterial O2 is decreased. So what about carbon dioxide now? Now in order to study about carbon dioxide, we have to think about two things. One is gradient and another is interstitium. What about the gradient? Whenever the carbon dioxide is moving from the blood to the alveoli, as there is a ventilation defect, the amount of carbon dioxide in the alveoli keeps on increasing because the alveoli can't remove the carbon dioxide. So the amount of carbon dioxide in the alveoli concentration is more in alveoli than the blood vessel. So the gradient has been damaged now. So the carbon dioxide doesn't move from blood into alveoli, and the carbon dioxide concentration in the blood increases. Similarly, in some cases where there is interstitial damage, the transport itself is not happening, so the amount of carbon dioxide in the blood is increased. So partial pressure of alveolar O2 is decreased, partial pressure of arterial O2 is decreased, but partial pressure of arterial CO2 is increased. Now, what about partial pressure of alveolar minus arterial O2? As alveolar and arterial O2 both are decreased, so the partial pressure of A minus AO2 is normal. Now, what are the examples for type 2 respiratory failure? We will remember it as three headings. One is generator, one is pump, and effector. Generator is what makes the signals, then pump is what causes the contraction, and third effector is our lung. First, generator. Generator is our brain. Whatever the defect happens to our brain, for example, it may be accident or it may be some drug related, anything which causes the brain to not function. In that situation, the respiration also won't happen, the ventilation won't happen, and it causes the type 2 respiratory failure. Now the pump. Any disease causing damage to bones and muscles, that is the chest wall. If anything causes damage to the chest wall, it constitutes the type 2 respiratory failure. For example, it may be kyphoscoliosis or myasthenia gravis of the muscles, etc. Now the effector organ. In the effector organ, we will remember it by SIC, that is our lung. S stands for severe ARDS, that is severe non-cardiogenic pulmonary edema. In mild to moderate cases, there is only inflammation, but in severe cases, there is damage of the interstitium. I stands for interstitial lung disease, and C stands for chronic bronchitis. Now let's understand about type 3 respiratory failure. Before understanding type 3 respiratory failure, in type 1 respiratory failure, the alveolar oxygen concentration is completely normal, but arterial oxygen concentration is decreased. So A minus AO2 concentration is increased. Now in type 3 respiratory failure, you just remember it as if any normal component from type 1 or type 2 becomes abnormal, it is type 3 respiratory failure. For example, in type 1 respiratory failure, the carbon dioxide concentration is normal. If it becomes increased, that is, for a long-term cases, the membrane damage patients also can involve the interstitium damage. In that situation, the amount of the carbon dioxide in the arterial is increased. Similarly, in type 2 respiratory failure, the A minus AO2 concentration gradient is completely normal. If it becomes abnormal, it is now called as type 3 respiratory failure. So, our 2022 patient had emphysema before. For now, because of long term, there is also interstitial damage which has turned to type 2 like presentation. So, combinedly, it is a type 3 respiratory failure. Now, anesthesia people define the type 3 respiratory failure in a different way. That is, during the pre-operative period, if at all atelectasis occurs, they say it as type 3 respiratory failure. Now, what is type 4 respiratory failure? Just remember type 4 respiratory failure as decreased cardiac output conditions. If any condition causing decreased cardiac output, there will be hypoperfusion to the respiratory muscles, which causes less working of the respiratory apparatus. Now there is one special condition, that is high altitude. In the high altitude, the amount of oxygen in the environment itself is less, so the amount of alveolar oxygen is less, so the amount of arterial O2 is also less. But what about carbon dioxide? The carbon dioxide, as the interstitium is normal, the membrane is also normal, so the amount of carbon dioxide concentration in the arterial area is completely normal. So partial pressure of alveolar O2 is decreased, partial pressure of arterial O2 is decreased, but the partial pressure of arterial carbon dioxide is completely normal. Now the partial pressure of alveolar minus arterial O2 is completely normal because both are decreased. Now let's summarize about types of respiratory failure. There is type 1, type 2, type 3 respiratory failure. Let's keep aside type 4 respiratory failure as it is not important, and let's also summarize about high altitude. Now partial pressure of arterial O2 is decreased in all types of respiratory failure. Partial pressure of arterial CO2 is completely normal in type 1 respiratory failure, and it is increased in type 2 and type 3 respiratory failure, and it is normal in high altitude. Now the gradient. Now the gradient is completely increased in type 1 respiratory failure and normal in type 2 respiratory failure, increased in type 3 respiratory failure and normal again in high altitude conditions.